pleasure to be here. Good morning, everyone. Yes, indeed, I'm Carlo Buontempo, and I'm the director of this Copernicus Climate Change Service. For some reason, my PowerPoint ended up containing part of my screen. We didn't manage to figure out why, but that's the way it is. So as a director of C3S, I'm often approached by media who are asking about extreme events and whether extreme events are caused by climate change. So I assume this is the, yep. So this is an event of 212 minutes in 3 hours, which is rather extreme. Was it climate change? Any taker? Well, normally when this kind of event happens these days, and we had many this summer, I shield myself saying, well, you cannot attribute a single event to climate change, but these are the kind of events we expect to become more often because the intensity of precipitation, blah, blah, blah. The interesting thing is that actually this event didn't happen yesterday. It happened nearly 60 years ago by the day. So this was the Riada, so like flash flood of Terrassa, and it was on the 25th of September, 1962. So literally almost to the day. And I think it's a useful reminder. So we had these extreme events throughout our history, and it's not, I mean, that's what makes climate interesting to study. It's not so simple as to say everything is linked to climate change. But on the other hand, there are many events that we can more confidently link to climate. And this summer was a good example of it. So we produce every month a monthly bulletin looking back at what has happened over the previous month. And at the end of the summer, at the end of the winter, typically we have retrospective analysis of what has happened over that season. And I'm not producing this bulletin myself. There is a team of people within C3S who take care of it, but they typically send me the draft before those are published. And when I receive the draft and I look at the anomaly, actually I thought it was an error, because last year we got the warmest summer on record, record-breaking summer, and this summer 2022, was hotter than last summer by nearly half a degree. Really staggering, and especially for people in this country, know all the sequence of heat waves that have characterized the summer starting from June and May even. So just to say, not everything is linked to climate change, but at the same time, climate is changing. It's changing rapidly, and we see a lot of the impact of this changing climate. So this was a bit of an introduction to what we do, because C3S is the most junior of the Copernicus services. Copernicus is the Earth observation program of the European Union, and is divided in a space component that is about designing satellite mission and sending those to space, and a service component that is structured over 6 services: atmospheric monitoring, ocean, land, security, and climate change. So climate change was the most junior to start, and actually it started before the Green Deal or the Paris Agreement were signed. So in a sense, you can see it as a good investment from the Commission. And now it really delivers towards the major objective, major priority at the European level. So what's in, I mean, this is becoming really important. When I started working on climate, maybe 20 years ago, the discussion was still about detection and attribution. So was climate changing? Are we responsible for it? And there was a lot of academic debate. And this is the World Economic Forum this year coming up with a global risk report. And I think what is quite interesting is that the top 3 risks, as saying by an organization that has nothing to do with climate, is really about risk, are all in some shape or form associated to a changing climate. So I think this is important to stress, because it means that our mandate is not just to study climate, understand how it works, but it's really to bridge that understanding towards society, ensure that reasonable action can be taken using the best of our knowledge. I'm not sure, considering the event of the last few months, that this risk register is still accurate. I think there are bigger risks at this stage on the horizon, but still, the fact that this was the recognition at the beginning of the year, I think is quite telling. And there is a challenge in that, and I think Josh mentioned it in his talk. And part of the challenge is that the data, the underpinning information is enormous, it's just gigantic. So this exponential growth in our computer capability means that we are also storing a huge amount of data coming out of models. And I make here the example of the archive of ECMWF, so of the IFS in particular, but similar argument can be made for satellite information or other sources of information. And I mean, the number are big in the sense that the archive is on the order of 400 petabytes. And I mean, most of us are scientists, and I think we understand what peta means, but it's also useful to translate those in something that is maybe a bit easier to understand. And something that I figure it out is that ERA 5, which is 12 petabyte, and ERA 6, so in between, probably ERA 6, that will be short of 100 petabyte, but in that order of magnitude. If you think about encoding 80 petabyte with an MP3 music, is roughly translating to music for 1 million years or thereabout. So you can think that is enough content, enough information to be the soundtrack of our existence on this planet. And this, I think, it tells you something. It's huge, the amount of information we have there. And if we don't design a suitable interface, that information, as Josh was saying, will stay there and make no difference. So this was a bit the motivation behind what we call the climate data store. And this is a fancy infographic, but the idea behind, I think, is quite powerful. So you have this huge amount of information, and it's not just model, although the example I made before was about model. It's observation from satellites, from buoys, from ground-based stations. Normally, those are smaller in size, but if you put everything together, it's massive. And on the other hand, you have this legislator, you have more and more business coming on board, as well as the society, citizen, decision maker at all levels. And so we designed this interface that maps this petabyte of data into a kilobyte of information in a traceable way. And something I often forget to mention here is the fact that everything we give access to is open and free, meaning that you can use it for any sort of application, this being research, business, or anything else. So that's behind it's the philosophy behind the entire program. And we have been quite successful with this effort. Yesterday, more or less 24 hours ago, we just passed the 150,000 user mark. So on the CDS, we have now 150,000 users, and we deliver to them roughly 100 terabytes of data per day, responding to 500,000 requests globally. Most of our users are in Asia and Europe, so China often being on top of the chart. Depending on the time, Europe is ahead, US, Japan, and so on. So what do we have on this infrastructure? Again, another top-level infographic, but in a sense that the climate is changing, the future is in our hand. We need information to deal with that, and information covers all time scale. So from the observation, and I will make the case that actually observation of the past are particularly important to understand our risk. It's not just about projections, reanalysis that remain our key and most important product, seasonal prediction, and climate projections. So let's start from the observation, and in particular, let's start from satellite-based observation. So we have adopted the concept of the essential climate variables as defined by GCOS, the Global Climate Observing System. And we have what is called a climate data record or multiple climate data record for each of these 22 ECVs you see in this infographic. So actually these contain all the ECVs, so these are 54. Those encircled in red are the 22 I was referring to, and those are obtained from satellite. Those in orange are not coming directly from satellite, but are mediated by reanalysis, so to speak. And those in different shades of blue are what we like to address next. because there are, I mean, the climate system is very well observed in many respects, and still there are some gaps, especially in terms of systematic observation. Some of these gaps are being addressed in the new implementation plan of GECO's implementation plan that will be launched very soon at the conference of the party of UNF CCC. Some other will still remain gap probably for the foreseeable future. And it's not just about satellite observation. Over the years, C3S has invested heavily. If you have a mobile phone and you want to know more and you're interested, you can scan the QR code on the top right corner of some of the slide that should take you to the web page where this information exists. So I was saying it's not just satellite information. A lot of effort actually has gone into in situ data. So these are, for instance, radiosonde. These are precipitable water from GNSS or land and ocean station data. And is part of gridded data set for Europe. Part of it is really putting the data together and making it accessible. And part of it is rescuing data. There is still a huge amount of data, not only in Europe, but in developing countries, that is not in a digitable format. And this makes it unavailable and inaccessible. So part of the effort is really going in this direction as well. And I mean, I don't know how many of you have young kids, but probably you are familiar with the story of the very hungry caterpillar that keeps eating and then becomes a beautiful butterfly. I leave to you to decide when or what the beautiful butterfly is, but in terms of eating all the data, we clearly have a winner, and is the reanalysis. Reanalysis is a phenomenal eater of data. This is because of the data simulation and the improvement in data simulation system of ECMWF, but it's also because an incredible amount of information has become available. And I mean, there are some figures here, which again are very big numbers. There are a couple of points I want to mention. One that I find particularly relevant is the fact that over the last 20 years, the composition of this satellite information has shifted. While 20 years ago was mostly North American, now Europe is playing a more prominent role. I think this tells a story because Europe has really taken the space and the climate challenge very seriously and has invested over the year a significant amount of resources. So our very hungry caterpillar actually managed to become rapidly and probably unsurprisingly the most popular product on the climate data store. So this is ERA5 reanalysis. You see here a comparison for the tropical cyclone Florence and making landfall in North America in 2018 between ERA interim on the left and ERA5 on the right. And you see several things there. You see a more realistic distribution of rainfall. You see also a less stop motion kind of animation because we have hourly data rather than 6 hourly data. And so on and so forth. And also because of this investment, ERA5 has become a very important element in the IPCC 6th assessment report, where the word ERA5 is mentioned over 240 times. So I think that's an achievement per se, let alone the scientific achievement of reaching nearly 4,000 citation in 2 years. But what is interesting, again, and I go back, because looking at extreme is not just about the projection, is very much about what has happened in the past. This is the famous, unfortunately, famous flooding of the Netherlands and also affecting Belgium and the UK back in 1953. And this is still in the memory of many, especially in the Netherlands, as being one of the major catastrophe of the region with over 2,000 fatalities. And what we did with ERA5 was to extend, also thanks to the data rescue activity, extend the record back to the 1950s. And this has allowed us to look at that storm. So just to give you an idea of how impactful that event was, what you see on top is a present that ECMWF was given by the Dutch representative when the building in Reading first opened in 1979, and the color used for that plot are quite telling of the fact that it was in the 70s. But what that plot represents is really the pressure patterns of this terrible storm. And what you see at the bottom, this is the work that our colleague Baudouin Raoul did using pretty much the same color scale, is the fact that the back extension, this reconstruction of a historical period of era 5, capture quite nicely that event. So this to say, now we have 80 years, 70 years of reanalysis, and these represent a gold mine of information if you want to assess your climate risk. So we are investing on era 5 and we are investing on era 6. So era 6 is in the making, in the sense that we are looking at what it means, what will be like, what cycle we will use, what will be the resolution, how much coupling will include. But it's quite clear there will be higher resolution than era 5, that will have some sort of coupling with the ocean and will be based on probably on 49R1 cycle, so a much more recent cycle, 10 years of innovation and R&D getting into era 5, era 6. And we do expect era 6 to start in Q1 2024, so become available around the end of 2026 or early 2027. And it's not just about global reanalysis. And again, if you are interested, you can take the snapshot of the QR code. We invested also on the regional reanalysis, both with SERA, which is a regional reanalysis for Europe, at 5.5 kilometers and 2.5, and CARA, which is a regional reanalysis for the Arctic, at the moment divided into 2 domains that you see here in red, so a Greenland domain and a European domain. But starting now, the simulation are basically about to start. We'll have a pan-Arctic domain at 2.5, well, it's not a given yet, but less than 5 kilometers, let's say, going back as much as possible, probably till the 80s. So we invested into the Arctic also because the Arctic is key for Europe. Moving a step away from the observation, so I mentioned satellite observation, ground-based observation, reanalysis. The next logical step in the portfolio of product are the seasonal prediction. We don't have subseasonal for now. There is no promise in our contribution agreement to make the subseasonal available. Nevertheless, there are discussions within ECMWF to see the opportunities or opening up some of these S2S dataset. For seasonal, there has been a constant enrichment of the offering, so to speak. So back in 2016, when we started making seasonal available, it was basically only graphical product. I should say that these are coming from a variety of centers. So basically all the global producing center in Europe. So this is ECMWF itself, Meteo France, the Met Office, CMCC, DWD, and we're also receiving in-kind contribution from NSEP, JMA, the Canadian model as of 2021, and probably sometime next year also the Australian model. As for all the other products, both the graphical output and the hindcast and forecast are freely available and can be reached publicly. And they are used, and actually I found we collect systematically statistics about our user. So everything is free, but you need to register. So we have a trace. And interestingly, the seasonal prediction are by far the product that has the largest fraction of private sector users. So you see up here the distribution of our user. We still have a significant fraction of academic, but we have slightly more than a quarter of people who identify themselves as being private sector. And this is also reflected in the many tweets from many different organizations who analyze our data and try to draw some conclusion about what's going to happen next. Interestingly, this summer, so this is the, on the left, you have the probability, the most likely category for 2 meter temperature. For June, July, and August, this is the May forecast. And what you have at the bottom, so left is temperature, right is precipitation, and what you have at the bottom are the anomaly as seen for the same period from era 5. And while there are clearly differences in some spots, especially over Europe, the anomaly seems to be well captured. What I'm not showing here, because I haven't added this slide, is the fact that actually if you look at the circulation, that's less well captured. So it goes back to understanding the mechanism. It's not just the statistical signal. But there was possibly linked to climate change, there was a signal that has been picked up by the multimodal system. And on projection, I won't say too much, but basically we give access to CMAP5 and CMAP6, as well as the codecs for Europe, so MET-codecs and EuroCodecs, and all the codecs domain globally. The effort has been to add functionalities on ESDF nodes that, for instance, allow user to subset the model on download, so reducing the volume that needs to be downloaded. And what we are working at the moment is really very much to connect to the IPCC Atlas. So this has been probably one of the most innovative part of the IPCC, but because of the IPCC design, it needs to be frozen. So it means that it cannot be updated. Is part of the report and needs to be static. So what we are working on with University of Cantabria is a way of updating the interactive atlas and make those available through the climate data store. I talked a lot about, let's see if it works. I talked a lot about data and access to data, but actually in that initial image that I showed to you, the idea wasn't just to give access to data, was to a bit, again, looking back at what Josh was saying, was to find mechanism to use that data and try to make sense of that data that were traceable and easily accessible. So this is an example of what we call an application. I don't know whether the animation will work. Yes, it looks like it works. So this is basically an interactive web page, and this is the most trivial thing you can do with Euro 5 is the global mean temperature, and then you have an extrapolation of the global mean temperature to see when the 1.5 degrees, as in the definition of the 1.5 degrees report of the IPCC, will be reached. You may like it. You may think that extrapolation of linear trend is too simple, absolutely justifiable as a criticism. But the important bit of it is that this is available to anyone, is updated regularly, so you can use it. And if you're interested, the data behind is free and open, and the code we use to build it is also free and open. So you can take that code, change it, improve the fit, do something much more clever than we have done, and run it yourself. So that's the idea of making that data accessible and easy to use. And we have done it for a large variety of examples. So this actually is an example looking at extreme event in Europe for precipitation, where you, if you define a time range, then these up return the magnitude of the event, the aerial coverage of that event, the ranking, and so on. And you can do it for down to not 3 regions, so provinces and the like. And for each event, there is a sort of a snapshot of the footprint of that specific event. Again, is an example. This was done entirely by us in-house. But the idea is that the data is there, the tool is there, the system is there and is open, and anyone can use it, copy, or do better. Another example, this is more on the seasonal prediction, and this is also benefiting from a very strong collaboration with CHEMS, the Emergency Management Service that ECMWF is running on the behalf of the Joint Research Center. And in this case, what you look at are seasonal prediction of river flow. And what you see on the left is a snapshot, I don't remember which lead time, I think it's 2 months lead time, that is masked using an RPSS score. So masking the region that have little skill. And I picked the Po Valley, and this is the September forecast. And you see the forecast there. Again, is an example. The data behind is open and free, and you can use it, but it's an example on what can be done. Probably the most visible example of our output is the European State of the Climate Report. That's what the ESOTC stands for. And this is published every year in April, typically on Earth's Day, on the 23rd. It's probably our most high-profile publication. And again, you can reach it by scanning the QR code. What we did differently this year in 2022 was to also include a section on key event. So events that were, for some reason, particularly impactful or interesting. So was the summer that I mentioned before. All right, sorry. Yeah, the European warmest summer, but there was the flooding in Germany and Belgium and the like. But there was also this event that attracted a lot of attention because it was one of the lowest wind speed on record. And in this transition we are making towards more clean energy mix, then wind power is becoming more important. So understanding our vulnerability to wind power is becoming key. So what you see here on the right is the ranking of the 100-meter wind speed in 2021, and in regions such as Northern Germany, Denmark, and the British Isles that have quite a large installed capacity. Then you see that 2021 ranked as being one of, if not the lowest wind in the record. So just a few examples, and we are now starting to prepare the State of the Climate report for next year. We are also producing a State of the Climate report with WMO Region 6 that will be launched just before COP at the beginning of November. But we are already thinking about the publication in April. And one of the discussions we just had last week was really to identify which were the key events for this year. So the summer heat wave for sure, but there have been many others, the drought that we are now discussing. So if you have a particular one you think we should include, please come and let us know. I just want to pick up here one of the key elements of what we do. This is, we call it the climate data store stack. And it's really the idea of moving from this petabyte of data, can be reanalysis, observation, projection, or the like, through a traceable chain through the information. So the application, the State of the Climate report. And this looks very nice and very polished, if you want. But actually, often it misses one important element, which is the feedback loop. So we have this engagement, these 150,000 users, and this is really the value of what we are doing, listening to what they need, what is missing, and so on. So we have an excellent, I'm terribly biased, but I really like that team very much, user support team. They are working very hard, and they are very good, according to our statistics, in responding to query from users. So this is our knowledge duck. You know, the symbol of ECMWF is this little duck. You can ask the knowledge duck whatever you like, and there is an AI algorithm behind that guides your responses through a set of existing material. And if your query is new, doesn't have a piece of information, then it reaches the user support team, which try to respond to you, but more importantly, keep track of your requirement so that we can evolve the system accordingly. And this is actually part of a very large effort that we put into what we call evaluation and quality control. So there are several aspects of that evaluation and quality control. One is about attaching to each piece of information enough quality attribute to allow the user to make sense of what we are doing. But the other is to have this systematic analysis of the user requirements. So these are taken on board, analyzed, and then we take action on those. The next few slides are about something that is about to happen. So I mentioned this concept of the climate data store, and I mentioned these applications, and some of them I think are quite nice. Again, very biased, but engaging and interactive. Nevertheless, if you are honest, most of them have been developed by us. So the system was designed to be open and free for anyone to use, but in reality there was too high, it represented too high of a barrier for the user really to engage and use. So we decided to change, and we are now working on something that will be called the Climate and Atmosphere Data Store, or CADS. And this is actually an environment that is much more open and much more modular than before. So the infrastructure is largely independent from so the system is independent from the infrastructure, is still based on Python, but takes on board, for instance, all that has happened in the Jupyter notebook world. So it will be much more based on Jupyter. It will be easier to interface with the catalog, but more importantly, it will allow users to interact with the data using their own laptop. So it's not really a closed system. You can develop and use the data as much as you like. So this the CDS toolbox will look similar, but you can pip install if you want the CDS toolbox on your system, on your laptop, on your computer, and use it offline if you like. This is very powerful. It comes with a bit of a pain point because this system won't be immediately back compatible with what we've done so far. So there is a bit of migration that is going on, but at the same time allows us to use it both on the cloud, which is the climate data store as it is now. So this is an example. It will be called CDS Lab, and it will run on the same infrastructure we have the CDS at the moment. But it can also be run on your own machine. So this is an example of this, of what I'm saying, where the CADS toolbox can be really run on another cloud platform, if you like. You can run it on your own machine. But clearly, in terms of efficiency, if you want to take advantage of the proximity to the data, the best way of using it is through the CDS Lab, where this will be a bit faster and easy to access the data with. But given that this is a big change, I thought it was a good occasion to let you know about it. This is my last slide, so I can leave plenty of time for question or discussion. And it's about the recognition that what we are doing at ECMWF and with the Copernicus Climate Change Service is a tool that will help the European society adapt to climate change, but it's not happening in isolation. There is a lot that is happening at national scale, and these are just a few examples of climate services or climate adaptation initiative in different countries. So we have noticed that we are working with some of them, but we want to do even more and really ensure that C3S is a resource for everyone to use. So something that we are launching next year is a national collaboration program, which is basically a small pot of money to support training, to support workshop, to support development of application or data set that address the needs of specific country or region. So this is still in the making, but if this is something you're interested in, or you know people who could be interested in, please get in touch. Thank you very much.
Thank you very much, Carlo. And now time for questions and discussions. And I think I start with one question. Think about all this impressive work in the C3S. Which have been the most unexpected success in your point of view during these years?
I wasn't expecting that question. I have to think about it. Yeah, unexpected success. Well, in a sense, well, I don't know whether it was unexpected, but when we started with the CDS, I remember when we reached 1,000 users, and I thought, well, that's great. We have 1,000 users, right? I wasn't expecting it to explode so much and to be so widespread. So when you start seeing people, not just in Europe, but all over the world, or reacting to what you're publishing, I think that's a success. And the level of queries from the user, I think, is also indicative of how much they care about their output. So it's not a superficial request; they are really in-depth requests. Yeah, I don't know. I have to think more for unexpected success, but yeah.
Yeah, from my point of view, this monthly bulletins, right. I see as such a success that I didn't see coming from the beginning, but when it came, it was a really great thing. So, starting, Nicholas, any questions from the Zoom yet? Okay.
Thank you for the presentation. At the beginning, you explained that the seasonal forecast is one of the main interests in the CDS, and you have a huge amount of users from the industrial sector. So if I'm not wrong, in the climate data store, the seasonal forecast is available around the 13 or 14 of every month with, and also it's not in the native grid. But then also you can buy the seasonal forecast and it's arrived the first day of the month in the native resolution. Did you analyze the difference between the private companies that are using the CDS and the ones that are paying for it? So it's, I mean, yeah, if there is any difference between the private companies that are accessing to any of them.
Yeah, I think that is a very good question. And we are aware of the difference. In a sense, we know who are the people who are paying for it. But I haven't done an in-depth analysis of that profile. My feeling is that given that you have a much larger ensemble here, that's of interest to some. You end up being a couple of weeks late, which for seasonal prediction is a lot. Also considering that most of the value is really the month 1 and month 2. So in that sense, I think it's something we need to analyze better. There is another element worth highlighting, and is the big shift within ECMWF towards open data. So at some point, other data set will become available freely. So this will also alter quite a bit the landscape.
Thank you.
Okay, Niklas.
Yeah, thank you. Really awesome presentation. I would like to know the CADS toolbox that you presented on the last couple of slides. So it's currently already available as far? No, it's not. Okay. And what do you think, and when would it be available?
Yeah, so the contract that is developing the CADS toolbox started in February. There was an initial phase that ended in July and was an analysis phase to scope out the requirement. And now they are developing the first version. The first version should be available by the end of this year, but it's basically a mock-up. It's not really a working version. So we do expect the release of the CADS toolbox around a year time from now, more or less. But okay. The principle, we'll try to make the principle or the information behind the basic architecture available sooner, because it's not, given that it can be done offline, it doesn't have so much interdependencies with the architecture of the infrastructure that we have. So in that sense, we should be able to provide some indication earlier than that.
And would it also include all these download functions that are now
all these, sorry.
Download yeah. Functions for getting the data, retrieving the data. So would it be a replacement for the current architecture, which is based on the CDS API?
No. The API will be largely unchanged. So the way of downloading the data shouldn't really be changed so much, which should be reassuring for many. I mean, at times there are small variation to account for a larger set of data. But the API won't change that much. What will change a lot is the way of writing the script. So the applications, the one I saw for the global mean temperature trend, for instance, the way in which that will be written and put together will be different.
Thanks.
Okay, next question, Niklas, in the front here.
Thank you. I would like to know if you provide any support to the users of all the products you propose, mainly the private sector, because we know that it's quite complex products and it can be difficult to extract interesting information, use it and communicate it for downstream services. Yeah, absolutely. So thank you for the question. Yes, we do have this user support team I'm very fond of. And that's probably the easiest entry point. So if you have a query, something you don't know, you don't understand, then you can contact them through the knowledge stack. But there is also plenty of information available. So each catalog entry has a tab. Well, first of all, it has an abstract that is written as much as possible in plain English, so without too much jargon. There is a tab that contains the documentation of that. There is a tab that contains the quality attribute. So if you want to know, what is the range, what is this data set, what has this data set been used for before, and so on, then you can find that information there. And there is a huge amount of information, technical and scientific information available behind. So depending on what is the level you want, or what is the level of your query, you can be directed towards different resources. There is another element, and is training. So it's another element in the program that we are
expanding. So there will be plenty of modules available, and Jupyter Notebook you can look at to see how to do things. Thank you.
A question about the new Cordex simulation you mentioned in your talk.
The new
Cordex simulations.
Yeah.
Are they based on CMIP6 or just?
Yeah, okay, that's a bit more complicated in the sense that in the first phase of Copernicus that ended last year, we actually funded some extra simulation. So the idea is for the Cordex simulation is you have the RCM, GCM, big matrix was trying to populate the full matrix. So we supported the development or the running of new simulation. We decided not to do it this time. So some group will generate their CMAP6 simulation, and we may consider adding those to the climate data store. But at the same time, we feel that at this stage, the way in which CMAP data is regionalized may actually change in the future, and it's not a given that going the route of a large ensemble of RCM, GCM is necessarily the best route for the users. So for instance, we have requirements from our user, some of which is, well, we have enough. We don't want more regional climate model simulation. We have plenty. So it's an open discussion, and we are discussing with the Codex office, with the CMAP office, and the National Met Services what the best strategy will be.
Thank you. So next question from the audience, Josh.
Right, really interesting. I like you. So you've got these really nice online products that you guys have been developing, and obviously there's the lots that you were talking about, all the tools to develop your own plots and stuff offline. Have you considered having a sort of user workshop where you can then put your own plotting scripts back online that maybe other people could then have a big user database to expand the space of visualization and make it easier for people to build off each other's work instead of starting from scratch all the time?
Yeah, thank you. That's an excellent question. There are two, it goes into different directions. On the one hand, we are actually building some sort of consultation process for what we call the super user or power user. So these are people, I mean, a small fraction of that 150,000 user is really made of user who really understand in depth what we are doing and the technicality of it, and actually listening to what they need is really important for us. So now that we are designing Euro 6, for instance, we are planning to have dedicated workshop or user engagement activities with this power user to collect their requirements. So that's part of the story. The other story is a bit more complicated because on the one hand, opening up, as we are doing the CDS, allows that innovation, and we really want to see it. It's slightly different if you then put those applications online, because there is a level of endorsement in doing that. So not everything that is produced is good, and we are prepared to put our reputation on. So there will be a process of distillation where, out of this bubbling world of innovation, every now and again, there is something to say, well, this is great, let's invest in it. But from that initial moment, having a mock-up that works and looks cool to something that is really operational, actually, it takes quite a bit of effort and energy. So we are not going to do it for everything, but for those things that we think are interesting as an example for others, then we will.
Thanks.
Thank you. Next question from the audience. Alvaro.
Thank you. And you have mentioned that the data is free for everybody, including companies and big companies of any sort.
Yeah.
So my question is in some sense the opposite to the Celine question. So have you considered to charge companies, not the small companies of course, but somewhat big companies or very big companies that are going to take profit from your data, which is very valuable, but maybe this is against your philosophy or is against the philosophy of some bigger entity behind you, like the European Union or something, or it's an experiment right now?
It's at the moment, it's complicated in a sense. We are aware of some big companies that are using our data. Not all of them are particularly keen to say that they are using our data or to make a big splash about it. Some companies are, and we are working with them. So here in Barcelona, for instance, there is Vortex. Vortex is a provider of services for the wind industry. And they have been one of our most vocal supporters, saying they were the company behind the Global Wind Atlas done by the World Bank. And they've done basically the downscaling, and it's based on ERA 5. So they are one of these power users we want to work with, and I can name many. Energy is particularly big, especially renewable energy. So there are many companies in that market, but it's not the only one. There are other markets that are equally, players in other markets that are equally engaged. Not all of them want to us to put their logo on our webpage, but when we find some and they are happy to share the story, clearly we are happy to.
So Niklas, anything more on Doom? No. So if you think about the reanalysis, how far back in time do you think it's worth to go?
So, well, for ERA 5, we went back to 1950, and now 1959 onward is available, and 1950 to 1959 will be available very soon. We are considering to push it back to 1940, so 1939. 1930 is still a possibility. When you get into the 1920, it's just, even in Europe, the data is probably too sparse to get something even, it depends really what you're looking at. For instance, the Southern Ocean, and in particular, Australia, is already under constraint in the early 70s because of the lack of satellite information. So for Europe, I think even for wind, you can realistically go back to the early pre-satellite era without too much trouble, I would think. But when you get into the 1940s, 1930s, I think there is a bit more of a caveat.
Okay, thank you. So I think we thank Carlo again